Hi there, my name is Zach Gurberg from MediLumine, and today I'll be demonstrating how to perform co-registration of two volumetric datasets within Imalytics Preclinical. So as we can see on my screen, we've got two volumetric datasets, one being our CT scan as our underlay, shown as a ISO rendering, and then we've got our overlay being our PET scan, shown as a volume rendering. And so clearly there is a misalignment between these two datasets, and Imalytics Preclinical provides a great module for fusing these two datasets so that there is no misalignment. So there are three ways to perform this fusion. One is based off of a rotation and a translation. So they're linear transformations of either the overlay or the underlay. And then there are two other forms of elastic transformations that I will demonstrate further on in the demo. So the first one I'll be demonstrating is a translation, and we'll be doing a translation of the overlay. And we can do this along an X, Y, and Z axis of a millimeter measurement. So if we do a translation of 5 millimeters along the X axis, this is what we can obtain. So obviously that would be too much for the bottom half, but not bad for the top half. So what we would want to do is maybe a rotation after. So you can do a rotation along, let's say, the Y axis of 5 degrees. So that's a little bit better, but we can see now that we need to perform another translation. So we can do this. And what's really nice is that it computes the actual transformations we've done so far from our 0 point. So we'd want to actually do maybe a negative 1.46 over here, maybe a bit less. We can do a negative 0.76. And so as you can see, for some purposes, this is all you need to do, and that would be enough. But there are two other methods that we can do that would actually allow us to get a little bit more exact with our co-registration. So what we're going to do is we're going to actually reset this by going and centering the overlay on the underlay. So this is what we started with. And so one way to do this registration would actually be through a segmentation. So we can hide our overlay, add a class called bone, perform a thresholding operation above center to our bone, to our bone on our underlay. So above center on our bone. Yeah, there we go. And so now we have our bone class over here. And so what we can do with this is we can show our overlay again and perform a fusion over here. We would set our input class to bone, and we can perform a fusion by going register overlay to underlay and perform fusion based on the image, and we'll start with coarse. So what you'll see is this computes the mean squared difference between the voxels and attempts to minimize this. So as you can see here, the registration is quite nice. The images seem to be quite overlapping, except for on the bottom part over here, which is unfortunate. So what we can try is doing this again through the fine-based. And so this maybe overlap them a little bit more, but this is the best we can get for this segmentation that was performed. Depending on the segmentation that you perform, it could be better, especially if you have fiducial markers in your data set. This would allow you to get that quite nicely. But what we can also try and do is do it through a marker-based transformation. So we're going to center both of these again. And what we'll do is we'll place our markers. So we're going to start by doing it on our underlay. So I'll actually hide the overlay. And what we can do is we can place our markers on the knees and the elbows of the underlay. So if I just adjust our viewing angle a little bit, and I go into our markers, I'll place left knee, then right knee, left elbow, right elbow. And then we can hide this and perform the same thing on the overlay. And we'll change our rendering over here to a ISO rendering so it actually looks the same. So we'll go white, and we will adjust our windowing so that we see everything in the same manner. So there we go. So we'll do left knee, right knee, left elbow, right elbow. And so what we can notice is I can, go back to our volume rendering. And we can change this to our NIH again. And view this again like that. And so what we can do is perform our registration using these markers by, again, going register overlay to underlay and performing this based off of markers. And so if we show our underlay now, you'll see that these are actually quite fused. And so this worked very well. And so those are the 3 ways of performing image fusion within Imalytics Preclinical. If you've got any questions, please feel free to send me an email. And thank you very much for watching the video. Take care.